I bet most of you in the last couple of days have applied some of the concepts we're going to be discussing today. Do you pay your dinner with a credit card? Do you get money from an ATM machine? Do you authenticate yourself before you can board a plane? Cryptography and authentication are two key security notions that are using our lives more often than we think. In this talk, I will give you an overview of all the Windows CE communication components. I will also talk about some of the work that we're doing for future versions of the OS. Before I start going over today's agenda, I would like to mention that I am very, very interested to hear what features, what OS security features you need to develop to create new products. At the end of the talk, George, our security developer, and I will have time for Q&A. Also, I will discuss other ways that you can give us your feedback. So here is the agenda. First, we'll talk about cryptography. We'll describe the components that we have in the OS, the cryptography service providers that we have in the platform builder, and also some that will be available on the internet. We'll discuss authentication support, and this is done through an SSPI layer, similar to NTs. And then we'll talk about secure channel, or SSL. This is something that is used, this is the most common authentication method on the internet. Then we'll discuss smart cards, and George will give us a demo of a smart card logon application. And then we'll describe options that OEMs have to modify their build environment to create more secure platforms. So here are the current Windows CE security components. We have this copy 1.0 layer that is included in the core DLL component. The copy 1.0 provides the same APIs as we have in NT, except for we don't support ANSI calls. We are a Unicode system, and we don't support running processes on another user context, security context. So we don't support those APIs. But otherwise, we have a very good copy 1.0 subset. Under this wrapper, we have two providers, an RSA-based provider and the RSA-enhanced provider. The RSA-enhanced provider contains 120-bit encryption components, and this can only be used in North America. And the RSA-based contains the 40-bit encryption components that we can ship to almost all countries in the world. Besides copy 1.0, we have this SSPI layer that allows you to plug in authentication providers. We'll talk about that later on. And we have two providers, SSL and NTLM. And we have easy ways to access S-channel. We provide a Windows sockets interface, and we have also a WinINet interface. And later on, we'll describe how you set up a Windows sockets connection that is secure, and also how to obtain HTTPS pages. So here is the architecture of Crypto 1.0. The beauty of this architecture is that you can isolate your applications for input-export restrictions. For example, you can create an application, you can sell it in the US, you can sell it in Germany, and the only thing that you need to change is the CSP. So you use the RSA base if you want to ship your product, let's say in Europe, and you use the RSA enhanced component if you're shipping your product in North America or Canada. Note that also you can have smart card service providers. So you can not only have software-based encryption algorithms, but also you can have some that use hardware assistant encryption components. For example, some smart card contain some cryptographic functions that are done on hardware, and you can have a CSP that will use those components. And note that you cannot just plug in. We provide documentation in the SDK and in the programming guides to create the CSPs, but you cannot just create one and load it on a Windows CE device, let's say a handheld PC device, because the crypto component will check for valid signatures of these CSPs. So you can create one, you can test it, let's say on an empty machine, but if you want to run it on a Windows CE device, you have to obtain a valid signature. And in order to do that, I will describe later on that we have a kit that you can use to first obtain test signatures, and then when you're ready to obtain the final signature, we have a website set up where you apply it, and we give the information to some government agencies, and they're the ones that decide whether you can get the CSP and whether you can get the signature. So as I mentioned before, the base provider has 512-bit RSA and 40-bit RC2 and RC4. And the enhanced provider contains greater than 512-bit RSA. The most common is 1024. And also you have 128-bit RC2 and RC4, plus DES and 3DS. And here is a pointer to a website where you can obtain information on how to get the Windows CE CSP Developers Kit. Actually, there is one CSP that works for Windows CE, Windows NT, and Windows 98. In the RSA base component and the RSA enhanced, we provide some of the most common uses of cryptography. We provide ways of people to do symmetric key encryption, public key encryption, digital signatures. We have algorithms to create hashes. We allow you to create keys and to store those keys. Here, it's an example of symmetric key encryption. Note that here you use the same key. So you have the same shared secret. And let's say you have some text that you want to send to a friend, Joe, for example, and you want to send it over the internet, and you want to make sure that it's encrypted. So with a symmetric key encryption algorithm, you encrypt it using this key, and then you send this encrypted file to Joe, and Joe uses the same key to decrypt it. The good thing about these algorithms is that they are fast. We'll see later on that public key encryption algorithms are slow, and they're mainly used for the creation of digital signatures. And actually, the CAPI 1.0 API will not allow you to do public key encryption algorithms to use them for bulk data encryption. But as you see, there is an issue here. How does Joe get this key? How do you safely give Joe the key? And that's an issue that is resolved with public key encryption. With public key encryption, you can create a session where you can safely send to another person this key, and then you can do a bulk type of encryption. This is how SSL does it, actually. So here is an example of public key encryption. Note here that you have different keys. You have a public key and a private key. And let's say Joe wants to receive email that is encrypted. So Joe generates this set of keys, and the private key, he keeps it in a safe place. And the public key is the one that he wants to advertise to the world. So this public key, it's usually distributed on an address book type of application, or using LDAP, or using directory X500 directory services. So you want to send an email, encrypted email to Joe. So what you do is you go into directory services, you obtain Joe's public key, and you encrypt the text or the data that you want to send, and then you send it over the internet, and then Joe gets it. Joe is the only one that will be able to decrypt the file because he's the only one that has the private key. Notice here that in order to communicate between two users, you have to have, any two users, you have to have a set of two keys. So if you have 1,000 users, you will need 2,000, you need to manage 2,000 keys. On the previous case, with symmetric encryption, if you have 1,000 users, for each set of users that you want to communicate, you have to have the same key. But if you want to communicate with another set of users, you have to have another key. So on asymmetric key encryption algorithms, if you want to have everyone in, let's say, a company of 1,000 people to use symmetric key encryption to communicate between each other, you will have to manage around 500,000 keys. And that's a very, very large number of keys, and it really becomes very difficult to keep track of those keys and to keep them in a safe place. An interesting feature of public key encryption is that you can create digital signatures. You can create ways on which you can tell that a message came from somebody and only that person, and the message was not modified. So later on, that person cannot say that, oh no, I didn't send that message, or that the message was not the same one that I sent. Because actually, with these public encryption components, you can guarantee that only the person that signed the message with his private key was the one that sent you the message, and with hash algorithms, you can verify the contents of that message. So let's see how that works. Let's say Tom wants to send a message to Joe, and Tom wants to say that let's say you have a contract, that he has a contract that he wants to send to Joe, and he wants to make sure that that contract is not modified in transit. So what Tom does is Tom signs this file, and by signing, it means using a hash algorithm. And a hash algorithm, you can think of it as a fingerprint for a message. This fingerprint is of fixed size, but for each different message, you get a different fingerprint. It doesn't matter what the size of the message is. It might be 10K, it might be 5 megabytes, but the size of that, the resulting value of the hash algorithm does not change, but the actual value changes. So what Tom does is he hashes that, and then he signs it with his private key. And then he attaches to the end of this document, and then he sends over the internet, and then Joe gets the message. So what Joe does is he gets Tom's public key, and he encrypts this message. And also, Joe, at the same time, computes the same hash, and then he compares the hash that he just computed with the encrypted message. And they should be the same. And if they are the same, then it means that Tom was the one that sent the message, and the message didn't change. This is actually these digital signatures are used in many, many places. It's a very important, it has many important applications in security. So that's what we have now. We're right now working on a Crypto 2.0 subset. And this Crypto 2.0 subset will allow you to do certificate handling. You can manage and store certificates. You can do change validation. You can parse certificates using ASN1 notation. We also will provide a storage of root certificates and user certificates, and also will manage the binding between certificates and key sets. We are just developing this Crypto 2.0 subset. So if there are APIs that you need out of this subset, this is a very good time to let us know. Copy 2.0 is very large, and we don't want to implement the whole thing in Windows CE, because I think, last count, I think it was around 500K. That's a lot of ROM space. And then if you multiply that times 1.6, 1.7 for some MIPS processors, you're talking about a big chunk of memory. So we are thinking about providing a very scaled version of Crypto 2.0. But we want to make sure that we provide the right subset. So please give us your feedback. Now let's talk about authentication. What is authentication? Authentication means the ability to prove that you are the one that you say that you are. For example, when you go to the bank and get some money, they ask you for a form of ID. You show them your driver's license, and then you have to sign some document, and they compare your signature. That's a process of authentication. They're validating that you are the person that you say you are. On the internet, it's more difficult to do that because you don't see the person, but there are ways of using digital signatures where you can prove that a person, digital signatures are an equivalent to, or certificates are an equivalent to driver's licenses that you can use over the internet. So for authentication, we have this SSPI layer in Windows CE that has the same APIs as the ones provided in Windows NT. It's modeled after the generic security service provider API. And we basically have all the APIs except, as I mentioned before, similar with Crypto 1.0, that we don't have a way of running a process under a different user context. Whoever is logged on the Windows CE device, all the processes are run under the user context. We have two service providers in Windows CE. We have an NT-LAN manager, security service provider, and we have an S-channel that provides SSL services. In the future, actually, we are planning to provide a server-side NT-LAN manager. So this means if you have a server, a web server, or if you have a server application that you want to run on a Windows CE device, you can store names and passwords in a local database, and you can authenticate users that way. Or also, if you have a domain controller, you could do a pass-through authentication. So if you have a user that you don't have it in your local database, what you could do is you can pass a request to a domain controller, and they can tell you, and the domain controller can tell you whether the user is a valid user in the domain or not. Let's talk about SSL. SSL is a very common authentication method, and it uses public key authentication to exchange symmetric keys that are uniquely derived per session. And after you have those symmetric keys, you can do bulk encryption of data across that channel. So secure channel allows you to protect your data. After you set up a secure socket connection, all the data that you sent over that particular socket is encrypted. We'll see later on that for secure channel, to enable a server to use secure channel, the server needs to get a certificate from a valid certificate authority. For example, VeriSign. You can compare VeriSign as the motor vehicle department that will give you a driver's license. And you can use a driver's license to prove your identity. on the network. So in this particular case, let's say Microsoft, I was told that the mouse here is also a little flaky, and I can see that you saw that a couple of slides just went by. Microsoft, before we set up the Microsoft.com website, what we did is we contacted VeriSign, and we asked them for a certificate. And that certificate is provided on SSL connections to clients to authenticate that you're actually connecting to the Microsoft website. As we saw before, okay, so you have this certificate that was signed by VeriSign. And then how do you verify that the certificate is correct and that the data has not been modified? You use the public key that VeriSign provides to decrypt that certificate and to make sure that the contents of that certificate has not been changed and that the certificate was actually provided by VeriSign. So that's an application of digital signatures that we saw before, and that's using it in S-channel. We provide, as I mentioned before, two interfaces, WinINet and Windows sockets, and the S-channel security provider has support for SSL 2.0 and 3.0, and also PCT 1.0. Although note that PCT 1.0 is going away, we're seeing that people are not using it very much, and we can save some space on ROM, so we're planning to remove it. SSL Windows sockets interface. I wanted to clarify that we only have client-side support, but we don't have client authentication support, and we don't have server-side support. There are some subtle distinctions. With a server-side support, you can create a web server that will validate certificates. We don't have the ability right now on this particular implementation of SSL. But a couple of customers told me that they would like that feature. So let me know if you need it. So I have more ammo to solicit resources. We also don't have support for client authentication. So that means clients cannot provide a certificate back to the server to let the server know that that client is the one that is certified by that certificate. So just to clarify that, because a few people came to me before and they thought that we had the feature, but we don't. But again, if you need it, let us know. So how do you set up a secure sockets connection? You initialize the Windows socket subsystem. You create a socket to communicate with a server. And then you call an API called setSockUp with SO_secure. And then you connect to the server. And then you have an extra step that is optional. If you want, you can create a certificate validation callback function where, as we saw before, there is a certificate that on a connection will be coming from the server, and then the client will be verifying the certificate. And we have these public keys that are provided from certificate authorities to verify those certificates. You could actually, SSL will tell you that that certificate is valid, but if you want, you can also look at the certificate and you can do some further processing. You might want to check the name of the certificate. You might want to you might want to deny particular certificates from a particular company. You can do that. So you have some flexibility there. And at that point, you're ready to transfer data. So whatever data you transfer on the SSL connection, it's encrypted. And then you can close the socket and clean up the Windows subsystem. So here are the root certificates that Windows CE has built in. As you see, there are a lot from VeriSign. There are different classes. We have a Microsoft root certificate. But you can easily add more certificates to SSL. And the next slide shows you how. You create a registry under HK local machine, COM, security providers, S-channel, certificate authorities. You create a key with the name of your certificate. And then under that key, you have these values. You have one for enable or disable, and one for type, that is a D word. And if it's one, the values for the certificate will be X509 certificates. And then you have binary data that contains the actual root certificate for the certificate authority that you want to have SSL verify. And S-channel will pick up the root certificate the next time it's loaded. You don't have to reboot the device. What you need to do is just close your application and restart your application, and SSL will pick up these new root certificates. Also under WinINet, we have a very simple interface to create secure connections. This means you can get HTTPS pages with just using one flag. It's called Internet Flag Secure, and you pass it to these two APIs, HTTP Open Request and Internet Open URL. So it's very easy to establish SSL and PCT connections using WinINet. And as you know, under current US law, strong cryptography products cannot be exported. But banks and other financial institutions ask the government for a way to give their customers access to their servers in a way that the data is secure. So the government approved some extensions to the SSL protocol that is called server-gated cryptography. And in order to enable that on a server, what a server has to do is obtain a special certificate from, let's say, VeriSign, and they will put that on their web server. And clients, when they connect to the web server, they will check whether that certificate enables SSL, enables server-gated cryptography. And if it does, then the clients can move from 40-bit encryption to 120-bit encryption on the fly. You don't need to upgrade your browsers. The SGC component is included in Windows CE 2.1 and above, and it just happens automatically. So customers that have Windows CE that, for example, are in Italy, they can connect to Charles Schwab using 128-bit encryption. And not only banks and financial institutions can get these special certificates, but actually you can apply to the Department of Commerce, and they will evaluate your needs, and they might be able to approve your request. Let's talk about smart cards. Here is a smart card. It's a portable computing device. There is actually a CPU here that is tamper resistant, and it has some programmable data storage, so you can save your private keys, for example. In the future, we're going to be providing support for the smart cards, and later on we'll talk to you about the architecture that we have to allow for writer drivers of readers. This is a smart card reader, for example. And also for smart card providers to write smart card security service providers or smart card cryptography service providers. Usually smart cards have a CPU equivalent to an IBM PC. It has a quarter of a MIP or so. And in many cases, they have RSA cryptography processors to do some very basic cryptography operations. They're not used for bulk data encryption. And they have 24K of ROM, where you can have DOS and applications. You have also a very limited amount of RAM, usually 512, that you can use to that your applications can use. And then you have this EEPROM data that is usually 16K, and that's a section of non-volatile area where you can store private keys, where you can store any data you want secure on the smart card. This EEPROM area, you cannot write it. It's very slow for once. It's not the same as RAM, and they have a limited life, so you can only write, in general, about 100,000 times or so. And there are different smart card OSs. There is actually now a smart card for Windows. I believe there's a presentation today that talks about that OS, and then there are many others, multi-OS, and many companies that make smart cards. They have their own OSs. So as I mentioned before, it's not terribly fast and has limited storage. But the beauty of smart cards is that it allows you to store private keys that are never exposed to machines that are using the smart cards. So your credentials can move with you. You can take, for example, your private keys. You can take your medical records. You can take whatever information is critical for you. George later on will be showing you an example where he saved the password, the network password of a Windows CE device on a smart card. And you can use that. And then in order to log into the device, you provide a PIN number, and then the password will be obtained from the smart card and use that to log on to the file system, to log into the Windows CE device so you can access the file system. So smart card enhanced software-only solutions. You can have a better secure email, you have better authentication, and it's great for e-commerce applications. So what is the architecture that we're trying to have in Windows CE to support smart cards? We have this smart card reader driver library that contains some helper routines, so driver-writer developers can use those and more easily port their drivers to Windows CE. Actually, this reader driver library, it's very similar to the one that is available in Windows CE, in Windows NT. We ported that from Windows NT. So if you're used to writing drivers for Windows NT, using that library, you should be familiar. On the top of that, we have these resource manager APIs that synchronize access to smart cards and to the smart card readers. And we have the same Windows Win32 API that is available in NT. So again, if you have applications that use these resource manager APIs, you should be able to easily port them to Windows CE. And then above the resource manager, you can write, you will need a smart card service provider to talk to a particular smart card. And if the smart card has crypto functions, you will need to put it on a separate module that will be under the crypto API. And then you have your smart card aware apps on the top. It's PCSE compliant, and we support smart cards that follow the ISO 7816 standard. So as I mentioned before, the resource manager manages application access to smart card and readers. It provides resource allocation across multiple applications. So several applications can be accessing the smart card, not at the same time though, as we will see later on. We support multiple smart cards and multiple smart card readers. And we manage the database of readers and cards. So later on you can search for a particular reader, you can search for a particular card. And there are many APIs that allows you to do session establishment, connection, to do connection services, communication services, card and reader access services, and reader control services. They are the same APIs that are available in Windows NT. So there are a few ways of locating smart cards. You can locate it trying to find a specific reader. You can try to find a specific card, or you can also look for a specific service provided by a particular card. And as we mentioned before, the reader driver library routines assist driver developers to port their drivers to Windows CE, and we have support for the T0 and T1 protocol. We have attribute handling capabilities and reader identification. So these are the components that we provide with Windows CE. We have the semlib.dll that contains the helper libraries for reader drivers, writers, and then we have resource manager APIs that are included on this smart card DLL and the smart card lib.dll. And then we're providing 2 sample drivers, so you can use those to develop more drivers for Windows CE. We have a serial driver. Actually, this is the Bull TLP3 serial reader. We have an SEM Microsystems Swap Smart PC card, and we're working with a couple more companies porting more drivers for Windows CE. So we'll have soon USB drivers and more serial drivers. There are a few things that are different from the Windows CE implementation and the Windows NT implementation. One of them is that smart cards cannot be used by 2 applications at the same time. So you need to, when you use a smart card, open the smart card, and then as soon as you're done using it, close it so other applications can also use it. The S-card auto-allocate is not supported, so this means that applications have to allocate their own buffers and then pass those buffers to the resource manager, and then the applications will have to free those buffers. NT has this auto-allocate function where memories allocated, buffers are allocated by the resource manager, but then the user will have to free those buffers. We decided to just have applications allocate their own buffers and free them. Windows NT supports asynchronous calls. Windows CE doesn't. So these 2 ioctls, ioctl smart card is absent and ioctl smart card is present, are synchronous. So in order to cancel those synchronous calls, you need to use the ioctl smart card cancel blocking call. So these are the components that we provide in the box, and then you need, when you buy a reader, you will have an installation program with the actual reader hardware and a driver, and then when you actually get a smart card, the smart card will come with its own service provider and an installation program. And now I have the pleasure to introduce George Joy. As I mentioned before, he's a security developer, and he will talk to us about the work he did to enable smart card logon in Windows CE. George.
Okay, so as Carlos said, I'm going to show you a little bit of some of the smart card support that just described. This is in a forthcoming version of Windows CE, so it's not there just yet. So what we have here is a simple application of smart cards. You're going to use a smart card as a hardware token to authorize access to this Windows CE device. So if you look on the screen here, what you see is the standard Windows CE shell. That's basically running natively on this box we have here. It's standard PC hardware, what we also call the CE PC. And I wouldn't pay too much attention to that version number in the small box. It might change. Okay, so the smart card I'm going to use for this demonstration here is a Schlumberger smart card. It's called the Schlumberger Multiflex. It's a fairly simple smart card. It has does not have any RSA encryption capabilities or anything like that. It doesn't use private keys. What it does have is access controlled file system and about 4K of EEPROM that you can use to save small files and things. And of course, we need something to actually read the smart card. So a smart card reader we're going to use is this PC card reader. It's made by STM Microsystems. And as you see, the smart card fits in quite neatly into the PC card reader. So I'm going to put in the smart card reader into our CEPC here. Now that's the standard PC card device. So the device driver gets loaded automatically by the PCMCIA DLL. And then I go ahead and put in the smart card in the reader. Now let me tell you a little bit about the application we're talking about here. Essentially, most of you have already seen the power on password feature that exists today in Windows CE. So if a user sets a password, then what happens is when the system wakes up from a suspended state, the user is presented with a prompt that essentially asks him to enter a password in order to continue and access the system. So we've basically modified that process a bit. So go to the control panel to set the password. This is the password prompt. So I enter a password here. The password does not have to be small or simple because I'm going to be saving this password to the smart card. So I click on Enable Password Protection. I also say I want to use the smart card to save the password. Now I've set up the smart card so that it requires a PIN in order to either read or write the password file on the smart card. So I enter my PIN here, and the control panel has saved the password to the smart card. Now I can take out the smart card and carry this with me. If I lose it and let's say Carlos finds it, he can't do anything much with it because he doesn't know the PIN number. So what happens if I shut down my system? Or rather, I put it in suspend mode. What you get here is the startup dialog. You notice that instead of a normal prompt for a password, it's asking me to insert the personal smart card. And in order to do this, what it's done is it's basically loaded smart card service provider DLL that knows the command set exposed by the smart card. And it's essentially going to use that DLL to verify the password. So let me put in my smart card here. When I do that, what happens is the resource manager gets notified of the card insertion, and it can check a sequence of bytes that's exported by the smart card to make sure that it's the right one that it expects. And once it's done that, it prompts me for the PIN to use. If I enter the wrong PIN here, I get a password incorrect prompt because the smart card does not give up the information that it's looking for. So this time I enter the right password and the right PIN, and what happens next is that the startup process essentially pulls out the password key file that is on the smart card, verifies that against the one that we set up earlier, and if it compares, then it gives me access. So that's basically how we modified it. Now, some people might actually want to go one step further and make sure that you cannot use the device without the smart card present. So let's see what happens when I pull out the smart card. The login thread was monitoring card removal events, and it noticed right away that the smart card had been removed, and it puts the system again in a suspended state. So that's basically what I wanted to show you. It's a fairly simple application here, but it actually uses pretty much all the infrastructure that Carlos mentioned just now. Back to you, Carlos.
Thank you, George, for the great demo. So, George, I'm sure many people are asking, was it hard to implement it? Was it hard to make the modifications?
It actually was not very hard at all. In fact, it just took me about a week to do that. And the components that I modified were the control panel and the startup dialog. And as it turns out, both these components are part of the source code distribution of Windows CE. So it's something that, yeah, the public distribution, you can do the same application if you want. Is there questions? Right. In the way this application is set up, no, not right now. It would basically insist on a smart card, but you could change it to do just that if you wanted to.
Well, I mean, that's the feature that's built into CE 3.0 when it ships, or C whatever.
Right.
If I don't have the smart card reader, like I forgot it, and I don't consider it have
right.
Will it revert to the password?
Well, okay. Firstly, this is not really a feature that's going to be imposed on you. It's just a demo for this purposes. So it's clear. It's definitely possible to do what you're saying. To make it revert to the password. This demo doesn't do that, but you can do that. Some people might think that's a bad idea because the very purpose of the smart card was to enforce the presence of this hardware token so that you have two pieces of identification. Get the PIN as well as the smart card.
So OEMs can choose what support they want to have on their devices. For example, some device for a military application might have a built-in smart card reader that can only allow access to a device when a particular smart card is present, and there's no other way to access the device.
So will that be a configurable option, or will I have to program that myself as an OEM?
If you're an OEM, then it's configurable. In fact, you can modify it, write it as you like.
There is a module that is called the Start UI module. That's the one that
That's
displays.
that's what you're seeing right there on the screen now, is the Start UI, and it's different from the one that's in 2.11. And essentially, the same changes that I made is something that you could do as well.
So right now, he modified the Start UI to check for smart card, but there's no reason why, for example, if you have a fingerprint recognition device or a voice recognition device, to modify your OEM device to accept those type of inputs. Thank you, George. So now let's talk about options that OEMs have to make their devices more secure. We have an executable verification feature that is available in Windows CE 2.11. And in Windows CE 2.0, we have a sample code that makes it easier to see how things work. By this feature, OEMs can specify which EXEs and DLLs will execute on their devices. What they do is they sign the EXEs, and when the kernel tries to load a particular EXE or DLL, the signature will be checked by some OEM code, and the OEM will make the decision whether to load that application or not. It checks for modules that are on the object store or external media. Modules that are on ROM are considered trusted, so they're not checked. And the OEM will have to implement two functions. One of them is called OEM certified module init, and the other one is the OEM certified module. And the OEM certified module will be called whenever EXE or DLL wants to load. And it will be passed the name of the image and also the actual binary date of the image. And then the OEM can make the decision whether to load it. So as I mentioned before, we have an example in 2.12. Some of the future things that we're doing to add extra security to Windows CE is to allow OEMs to choose whether a particular application has limited access to Windows CE APIs. And now the OEM certified module can return 3 values. One of them is the value false or true that it was returned before, but now it can return the value run and also this OEM certified trust. So when the OEM has analyzed DXE or DLL that wants to load and checks the signatures, now there will be 2 types of signatures. Some that will say that that particular application have access to all the Windows CE APIs. And then there is another type of signature where applications will have access to only a certain number of APIs. And here below are the APIs that applications will not be able to access if the signature for that exe was set to OEM run. So we were looking at all the Windows CE APIs, and we're trying to see which APIs can cause harm in the system, which APIs can allow, let's say, memory access to other processes. And we took that set, and now we're preventing applications that run under this mode to use those APIs. We also have a couple of APIs that drivers can call to determine what is the trust level of the calling application. So if a particular driver does not want to allow applications to be used on run mode, then they cannot accept particular calls from those applications. This is something similar. There's another API that DLLs can use. It's called CEGetCurrentTrust, and this will allow DLLs to determine the trust level of applications. So for example, if you're writing an application and you only want it to run on trust mode and not on run mode, you can check that and disable or not load your DLL. And the kernel always checks the trust level of DLLs, and it compares with the trust level of the application. So the kernel will not load a DLL that has a lower trust level that an exe has. So for example, if the exe has a trust level trust and the DLL has a level of run, the DLL will not load. But if both exes and DLL that is trying to load, that the application is trying to load, have the same trust level, then they will be running at the same trust level. For example, trust and trust, the resulting trust level is trust. If you have a run and a DLL that is at trust level run, you will have the resulting trust level to be run. If you have an application that is using the trust level run and you have a DLL that has a higher trust level, the resulting trust level will be the lower, which is run. Also, several OEMs complain that applications can modify the registry, and sometimes they can prevent the device from loading. So what we did is we write-protected the registry. We write-protected critical keys on the registry, so people cannot make changes, and they cannot, for example, take device drivers out that might, for example, if you take the display driver out, the device will not load. Now you won't be able to do that. And as I mentioned before, we have this Start UI module that OEMs can change to customize the behavior to access a Windows CE device. So as we saw before, George modified to look for a smart card. You can modify it to look for a fingerprint recognition device or a voice recognition device or whatever really you desire. Our goal in the security team is to provide you with the best security infrastructure possible. And as I mentioned before, we want to enable many cool devices and applications. But we are relying on you to tell us what you need. Right now, we're in the planning phase for Windows CE 4.0, and your input is critical at this stage of the game. So if there's a particular security feature that you need, talk to us soon. So here's how you can contact us. There is an alias that is called cetalk@microsoft.com that you can send us your security feature requests. We also have a session tomorrow on Ask the Experts. And we have the Windows CE website that contains information on all the Windows CE components for developers and also for OEMs. And for licensing information, there's an email alias. It's called WCOEM. Now, I would like to invite you to our Q&A session. Please feel free to ask about our present support, but please know that we might not be able to answer questions about future support. George, could you step to the podium, please? Thanks. If you want to ask a question, please step to the microphone. I think there is one in the middle, and speak loudly and clearly so we can all hear you. Thank you. Yes?
In terms of your current support for Crypto API v1, is that supported in palm size implementation of Windows CE? And the same question for NTLM and S-channel SSPs.
Okay. The
Go ahead. I think it is answered yes.
The crypto APIs are supported in the palm-sized PC and also in the handheld PC. And the NTLM manager provider, it's included with the browser, so you can access websites that use that authentication method. So it's also there. Let's see, it's S-channel, it's there. And also, actually, we have now a new port of Windows CE, of the WinINet component that uses NTLM too. So I don't know whether the NTLM component was provided with the current version of the wallet-sized PC.
Yeah, I'm not sure either.
I'm not sure, but the new one has some hooks on the WinINet component to allow access to that SPI, and we're talking about including it, but things can change.
What is Microsoft doing to allow the rest of the world to use strong encryption?
Can you repeat that question?
Yeah, what is Microsoft doing to allow the rest of the world to use strong encryption, and how, for example, do you, or are you trying to get the trade ban lifted, or alternatively, are you perhaps developing, shall we say, similar applications in European, Middle Eastern countries which don't have those trade bans?
Okay. We are going to be providing the strong encryption components over the web. And actually, right now, we have the S-channel components that people can download, but we don't have the RSA enhanced components on the web.
But he was talking the rest of the world.
But Microsoft is lobbying the government to allow the export of 120-bit encryption components. And we have now a lobbying group in Washington that are trying to push that, but the government is very cautious about that.
I guess the one thing we do have is server-gated cryptography, which Carlos mentioned earlier. That can only be used, of course, with specific sites, but it's something. The other improvements we hope to add in the future is to change the default export secret key size from 40 to 56. It's not there now, but we hope to add that because the government's now allowing that.
You mentioned the components were available for download over the web. Historically, when secure components have been available on the web, they've been blocked to, sort of, for example, UK customers. I assume that's now no longer the case.
Okay, the S-channel components that right now are on the web, the web server will check the location, the IP address of where you're located, and if you are outside the United States, you will not be able to download those bits. Same is done in the same manner as the 120-bit encryption component for NT.
Okay, thank you.
What are your plans for Kerberos and CE?
We're receiving more and more requests for that support. Right now, we don't have resources allocated for that, but we know that people want it, and we're investigating the work. Thanks.
Under one slide, you talk about protected registry. So is there any plan for OEM to protect the custom keys?
Is there any plans for OEMs
To protect, let's say we manufacture a device and we add in our keys, like configuration, but we don't want any non-trust app to change it. And I'm seeing this list, and it seems like most of those are system keys.
Exactly.
So is there any way that we could protect our customers' keys?
Not right now, but
Smart cards will be the only
yeah, thank you for the feature request. We'll think about it, and we'll see whether we can put it in. Thanks.
Extended Authentication Protocol, EAP, is a new feature of Windows 2000 for dial-up access. Do you have any plans for providing that under Windows CE?
We don't have allocated resources, but we have here a couple of customers that want it. It's on our wish list right now.
Okay, you can
Let me
add
know-
us to that list.
Okay. Give me let's talk at the end so I can have a little more ammo so I can bring up the feature request.
Hi, Carlos. Hey, George.
Hi.
Questions about S-channel. Can you give me an idea what the footprint is of S-channel?
The footprint now for the current version of S-channel is about 100K, I believe. That's on the x86, and I think it'll be probably 50% higher for other CPUs.
Okay. Second question about S-channel is, do you have any plans to incorporate TLS support?
We are considering that for upcoming release, yes.
We have received requests to support server-side authentication, also client-side authentication, and we're considering doing another S-channel port that will provide support for TLS and the last two features. But the only thing is the size of S-channel might grow, so we're considering the pros and cons.
Last question. I'm looking for information about configurability of S-channel for user-defined transport mechanisms.
So you want to use S-channel for something apart from connecting to websites? Is that right?
Say that you had a transport mechanism that wasn't TCP/IP.
Okay, right now I guess there's no way to do that, but that might change in the near future when we get to this next port of S-channel. It's kind of partly governed by actually the government restrictions and things like that, rather than our ability to do that. They just don't like the government doesn't like the idea of a general purpose encryption interface. It hasn't so far. That's changing a bit, but that's basically what's been slowing us down.
And also some governments don't like that, so for some countries we have to get approvals to expose certain protocols and certain API interfaces. We want to give customers more flexibility on using the cryptography algorithms that we have in the system, but there are some legal issues that prevent us.
A question about your smart cards. There's nobody in line behind me here, so you're talking about putting RSA on a smart card, but I'm concerned, and one of the hardest things to do is key generation on a smart card, and it seems that you may not be able to solve that problem. I wonder if you have any experience with trying to do that.
Yeah, key generation, I think there are smart cards available now that can do key generation. And the one that I used for this particular demo doesn't have any crypto capability at all. So, but there are certainly smart cards that can do key generation. They can generate the key and then keep the private key on the smart card, and basically it never leaves the card at all.
Which it would seem to me to be most people involved with security to be just about the only way you could really be sure that the user's identity was associated with that smart card. Any idea what the price point is on those cards?
I don't have that information right now, but you might get a little more answers to that if you go to the smart card for.
There's a smart card OS talk. I think this is Scott Guthrie. He works in that team. He said that he will be here, so you can try to find him in the Ask the Expert session. He should be there tomorrow.
Okay,
and he's the one actually that is developing the OS, and we're developing a very modular OS, so you can specify what components you want in the smart card. If you want a file system, if you want an RSA component, if you want, whatever.
A follow-up question then along the same lines. Elliptic curve cryptography is very well known for being efficient on small devices. It's considered to be ideal for smart cards. Have you guys been looking at the possibility of using elliptic curve to do those same sorts of signature operations? I understand you can do a signature generation no problem on a smart card with elliptic curve. You can sign in small devices no problem with elliptic curve. Have you any plans in that direction?
We are actually right now investigating providing some support for elliptic curve cryptography, but it's a little premature to say anything at this point. But we are interested, and if there is a company out there that wants to work together with us, we'd be happy to do that.
Thank you.
This is a system question, but it has some relevance to security discussions. I need to have a reliable way of getting a unique identifier for each device, something like a system called get device ID or something like that, to be able to use that to obscure some secure data. Is there such a service on Windows CE, service call that gives me that?
We have been looking at that for some products that we have in mind. There is an initiative for digital rights protection software where you can protect video or you can protect audio content or text content, and such a feature is very important. Many OEMs are actually going to be implementing hardware-based solutions that will provide unique serial numbers, and you can use those to generate other random numbers. But also, we want to provide, if the hardware is not provided in the system, we want to have some hooks on the kernel that will use some low-level, very granular timers to create very unique numbers. And we're not sure whether that feature will make it into 3.0. But
yeah, actually, I'm not looking for a sort of a random number being generated. I'm more looking for something like a serial number for a given device, so that it's always the same as I.
Right. Yes. So I guess the best way to solve that is for the hardware itself to provide the device ID. And that would be the preferred way, but we are also thinking of a software solution if the hardware doesn't provide that.
Okay. So providing a number that is uniquely unique.
Yeah, and if there is
repeated.
and if there is a call to get that something.
Right.
Exactly.
Like a Win32 call.
Yeah, we've heard of that request from
many other companies.
Thank you.
Is there any possibility to protect certain files or database, for example, from being accessed from unauthorized people?
The file system is not encrypted right now.
Okay.
And the database?
Right. I mean, there's no such mechanism in Windows CE right now. I mean, once you have access to the device and ability to run programs and things, you pretty much, it's open house and you can get anything from the device. So I guess it is possible for, like, if you're trying to, if you have kind of a server kind of application and somebody's connecting to you remotely, then you could use one of the mechanisms that Carlos talked about, such as the NTLM local user database or the NTLM pass-through authentication to verify that the user who's trying to connect to your system is authorized. But if somebody has physical access to the device, then we don't really support the concept of multiple users.
Okay.
My question is a follow-on to his question. I was looking at your sandbox model. The first thing that this gentleman noticed is that there's no fine-grained security limitations on the file access. What about databases and object stores? Do you have a migration path for your sandbox model for being able to restrict access at various levels to either the system registry or to the file system components or system components?
The registry is access, right? And serial proposed.
Yeah. We're going to be providing access restriction to the database, write access restriction. We're also considering read access restriction, but it is a lot more work and it complicates the kernel. So we're not sure whether we can provide that this time. Those are
the registry, right?
For databases, we have a feature request to be able to encrypt databases, in particular when you want to put them in external object stores, and also the file system. And we're also considering the ability of having multiple users on a Windows C device, and when you log on with a particular user, you want to have a private directory that only that user can access. But these are just ideas that we're toying with, but we haven't actually decided to implement them.
Actually, following up on that, can you say what that write and read access restrictions will be based on if there's no concept of multiple users?
Exactly. So we have to develop an infrastructure, and it's not going to be easy because Windows C is not a protected OS like NTs where you have security objects all over the place. But we're considering the only issue is that if we go this route, we have to do it right, and it will grow the size of our kernel. So we're a little hesitant to do that, but we're considering the options to allow for that ability, having multiple users on a Windows C device. But it is not an easy problem to solve, and it will complicate the architecture of Windows CE. So we haven't decided that we go the route.
Okay, that's it. One more.
Are you exposing this OEM certified module call at Win32 API level?
We're exposing it by the OEM adaptation level. So OEMs can implement whatever routines they want to verify how they want to verify EXEs.
Yeah, I think this situation, so I know that's a loader hook. So, but if you're copying an executable with the same name over this executable, for example, in the object store, so the well executable is gone. So I have the wish of a mechanism to keep the copying process safe, to validate the executable which is copied over the old one.
Yeah, I think that's it. Yeah, there's actually going to be the OEM certify module calls will also be available through kernel ioctl. So you can make the calls from an application, but the actual implementation would be in the OEM layers.
Thank you.
I have a question about the demo. I was wondering how the resource manager actually identifies the smart card. You briefly mentioned that it did check some bytecode or something.
Right. Well, one thing that's common with all ISO 7816 smart cards is what they call the ATR, the answer to reset. It's kind of an identification string that is sent out by the smart card. So that's one way to identify a particular class of smart cards. So essentially that the smart card service provider, DLL, was looking for the specific string of bytes that corresponded to that multiplex card.
So when you save the password, basically the control panel keeps track of the ATR?
I mean, this particular demo actually was specific, would require the card that I showed you. So you need the multiplex card. If you used any arbitrary card, it wouldn't work because smart cards differ quite widely in their capabilities, and there's no real standardization except at a very low level.
I missed some information on the DAP stuff, so why wasn't it in your talk?
Pardon me, could you repeat that?
I missed information about the dial-up bootloader stuff.
Okay, that's a good point. No, we don't have it. Okay, I will mention it next time. So there are some encryption components in the dial-up bootloader that will check the signature of an image. So people cannot just download any image they want. There has to be a signed image, and the bootloader will authenticate that image, and then will load it on the system on flash. Thanks again for attending this session.